Today we are going to be analyzing data using different displays, and so let's take a look at some of the different questions that we might end up experiencing. Here's one way to display data, and that's using a bar graph, and that's what we're going to be using for exercises 1 and 2 here. The bar graph shows the activities in which most injuries occur for children ages 5 to 14. Use the graph for exercises 1 through 3, and actually they just mean through 2 here because this they made a mistake in their writing. So this is only through exercises 1 through 2. Well, looking at the first question here, which activity has the greatest number of injuries? Well, let's take a look at our bar graph. And I look at the title, it tells me what the different activities or what the different aspects of the bar graph give me. So we have activities and injuries. So down on the x-axis, the horizontal axis, we have the different activities. On the y-axis, we have the injuries. This is the number of injuries. And so we want to find the one that has the greatest, the activity that has the greatest. We look at these different activities, and we want to find the one with the biggest bar, the highest bar, because the number of injuries we have more injuries when we go up this axis. So when I look at softball and baseball, that has the lowest number, and soccer has a little bit more. Playground injuries, well, that's a little bit more. Roller skating or roller sports has a little bit more. Football has a lot more. But then basketball has even more than that. And slightly more than that is bicycling. So that's the one that has the most. So you just look for which line is the longest, or which bar is the highest, is what you're looking for in this case, because it was the greatest. If it was the least, then it would be baseball and softball, because that has the lowest bar. Well, now they're asking about how many children are injured playing basketball. How many more children are injured playing basketball than soccer? So many more. That means that we're going to end up having to do something with those two amounts that were given. Well, how many more tells me I need to subtract those numbers. And so the first thing to do is to find the amount of injuries with basketball. So let's write down basketball. Well, okay, so we've got, looking at the chart, looks like it's just over 400,000. Well, bicycling's probably about 410 or so. So this, I would say, is about 405. So that's my guess to what that number's about. 405,000 is what basketball is. So we'll write that number down, 405,000. And now the next one's soccer. So now we need to go over to soccer on the activities, and then go up the bar until we reach the top, then go straight across, and you need to read that number. So it's about right here. So it's a little less than 200,000. It's not quite 190. I'd say about 180 or so. If you said 190, that's pretty close. But I'm going to go with 180,000. Again, they're just saying about how many. I mean, this isn't exact science. We're just trying to estimate because they're saying about. And so we go ahead and do the subtraction here. And we have to borrow eventually right here at this stage. So show that in a different color. So I'm borrowing from the 4, changing it to a 3, and changing this to 10, and then doing the subtraction. So let's see what we get when we do that. So 10 minus 8 gives me 2, and then 3 minus 1 gives me 2. So there's my answer. 225,000 is my answer for the number of children that get hurt playing basketball, the number of more children getting hurt playing basketball than soccer. So we'll write that in the line provided. And moving on to the next one, this is asking us to look at this circle graph. So the circle graph below shows the results of a survey of 200 people. Well, you're going to need that number eventually, so let's hold on to that number. That's a good one to underline. Who were asked about their favorite breakfast food. Use the graph for exercises 3 to 5. Did more people pick cereal or eggs? Well, let's take a look at cereal. And let's look at this and think of this like a piece of pie. And then you're trying to figure out which pie is bigger, which piece is bigger. There's cereal. And now let's take a look at eggs. So here's eggs. So which piece is the bigger piece? If you're going to have a piece of pie, which one do you think you would take if you wanted the one with more? Well, cereal is definitely bigger. If I cut it in half, it would be right here. And so cereal is this much more, this little extra section more than eggs. So cereal is definitely the one that has more in this case. So did more people pick cereal or eggs? More people pick cereal. Now they're asking about this toast. So let's take a look at this part here. So about what percent of people pick toast? Well, what you should do is break it into something that you know. Right here, if I took just this is called a quarter of the circle. How much is a quarter? What percent is a quarter? So this whole region here is 1/4, which equals 25%. But that's including toast and other. So what we want to do is we want to take away a little section. We're going to erase this amount right here. So this part right here, we're erasing this amount from this 25%. So how much is this? Well, this is where you have to approximate. So I would say that's about 5%. So all I'm going to do is take away 5% from 25%, and it gives me my answer of, well, that's about 20%. And that's what I would put down as my answer. So it's just an approximation. I knew that together the other and toast was 25%, and then I had to approximate what the other was, and I approximated that to be about 5%. Well, let's take a look at the next one here. According to the survey, 25% of the people chose pancakes. Well, here's 25, definitely 25%, because it's a quarter of a circle. And how many people chose pancakes? Well, that's where we underlined this part right here. This was the important bit of information we need for this problem. There are 200 people that were surveyed, and so all we're going to do is take 200 of 25%. And so there's two different ways we can do this. Of means we're going to end up multiplying. So we're going to end up multiplying 200 times by, and we can change this to a decimal, 0.25. And then you can go ahead and multiply these two numbers. Now when I do this, I like to do 2 times 25. 2 times 25 is 50. And then I go ahead and bring down these two extra zeros, 1, 2, and then move that decimal point 2 spaces over, because there's two numbers after the decimal point. So there it is. 50 would be the answer. So 50. I could also go this way. I could also think of 25% as a fraction. And so 25% as a fraction is 1/4. So it's 25 over 100, and it will reduce down to 1/4. And then from here, you could treat this 200 as a fraction, 200 over 1, and then reduce. How many times does 4 go into 20? 20 goes 5 times. Well, that goes in evenly. So you still have to bring up this 0, so that makes 50. 50 times by 1 is 50. So two different ways to come up with the same answer. 50 people would be our answer. Well, let's take a look at the last set of directions, a different way to display the table. And this is a graph with points and then a curve connecting these points. And so what we're going to end up doing here is answering this question about when did the U.S. population have the greatest increase. So the greatest increase is where is the line the steepest. So you see how they're connecting these points, it looks like, with lines. Definitely right here, you see how it's going up, it's gradually going up. Here it's getting a little bit steeper, here it's a little steeper, here it's not so steep. So between the years of 1920 to 1940, the population didn't increase as much. But here it starts to increase a little bit more. Okay, this is pretty steep right here. This could be an answer, definitely steeper than any of these. So this is one of the steeper ones. So when I'm looking at this, again, we're looking at steepness. Steepness, which is the steepest one? Well, this is pretty steep right here. And looking at this one, not as steep. It looks like it's going off to the right a little bit more so than to the left. Here, this one's pretty steep too. And so let's take a look at the numbers that they give us. So here, this one is about right in between these two, 275. Here it is about 225. Okay, so it's increasing here from 275 to 225. And so I would say this is 50,000. It increased by 50,000 on this one. Let's take a look at this other one. I'll highlight it in blue so you see the difference here. So we go over, and I would say this is right in between these two. So 150 to 200, so that's about 175. And then I look at this part right here, and this one is not quite right in between. It's a little bit closer to 150. I would say this is more like about 130 or so. And it's not 125. It's definitely something a little bit less than that. Maybe even 140. So I'll go with 140. And I subtract these, and I have 0, 0, 0, 5, and a 3. So you see how this one right here, the first one I did, this one was the greater number because this one's not quite in the center between these two. So you could have said 130 and it still would have given you 45,000, which would have been less. So definitely this is the steeper range. This was the steepest, so the greatest increase was the years between 1980 to 2000. Now I can go with the way I was doing it because the difference in the years was the same. See, this was a 20-year difference here, and this was a 20-year difference. All the points are 20 years in difference. So now they're asking, well, estimate the U.S. population in 1970. So let's go ahead and try that part. And so when I take a look at 1970, it's in between 1960 and 80. So here is 1970. Write that part down. And so what I'm going to do is I'm going to carry a line up. Now go right in the center here. And once you hit that line, then bring it over. Go straight over and figure out what that number is. Oh, it's right there, 200,000. So that's what my approximation would end up being. So 200,000 population increase. So it increased by 200 million because it's in the millions. So let's go ahead and add on some extra zeros there. So there it is. So these numbers here are added on extra millions as well. Wasn't looking at the units when I was doing the problem, but it still gave me the answer I was looking for. So those are some of the problems that you're going to end up seeing on tonight's homework, looking at graphs, doing some estimation, and understanding what the graphs are telling us. Good luck on tonight's homework.